yeah, we started quadratics, we saw 3 notations, and we saw 3 forms of writing a quadratic equation. And now we want to do how to convert standard form to the vertex form and to the factored form. We did the method of factoring, then we did the method of completing the square. Completing the square method is useful when we have to find out the vertex of the parabola or the minimum value or even the maximum value. We'll do the maximum value when we do features of parabola. We'll do that today. Then we also started the quadratic formula. Quadratic formula would be useful when we have to find out, when we have to determine the nature of roots, whether the roots are going to be real and distinct, or one real root or 0 real roots. Okay. So Anishka, today we are going to do number of x-intercepts, system of linear and quadratic equations, sum and product of roots of a quadratic equation, and some special cases. I don't know if we would be able to finish all the 4 topics, but we'll try to do that. Okay. Okay, so the first one is number of x-intercepts. This is related to the last topic that we did, nature of roots. Okay, so we did, actually let me go back to the previous class. Yeah, we did these 3 cases, Anishka. When you have 2 real and distinct roots and 1 real root or 0 real roots. So the first case, now we have to connect all the topics together. So in this topic, when we determine the nature of roots, when you get 2 real and distinct roots, in this case, when you will draw the graph of the parabola, it is going to intersect the x-axis at 2 points. Okay, in the first case. And the number of points of intersections, they are also called x-intercepts, where the graph is intersecting the x-axis. Okay. So there will be 2 x-intercepts when you have 2 real and distinct roots. And these points, the x-intercepts, they will also be the roots of the quadratic equation. Okay. So in the example that we did, x square minus 5x plus 6, here we got 2 roots, 2 and 2 comma 3. Right. So here this point is gonna be 2 comma 0 and this point is going to be 3 comma 0. So these will be the roots. Okay. So you will have 2 x-intercepts when you get 2 real and distinct roots. In the second case, what will happen?
There will be there'll be only one intersection or one root.
Yes, and this time we won't use the word intersection. We will say that the parabola will touch the x-axis, because when we say intersect, that means it is crossing the x-axis. So in this case, we say that the parabola will touch the x-axis at just 1 point. Okay, so I'll also write this here. This is the case of 2x intercepts. 2x intercepts. This is the case of 1x intercept. Okay, and this point, which is the point at which the parabola is touching the x-axis, that is going to be your 1 root, and this is going to be whatever, let's say a comma 0. Okay, and the third case, where you don't have any real root, that will be the case when the graph will not touch the x-axis at all. Okay, so the graph will lie above the x-axis. Like this. It won't be below the x-axis because otherwise the tails will touch the x-axis. Now this is the case when the graph is not touching x-axis at all. So here we say that this is the case of 0 x-intercept or 0 real roots. Okay. Now if you remember, we did this question where the question was framed in this way. They had given an equation, x square minus 5x plus c is equal to 0, and we had to find out c when there were no real roots. Now the same question can be created like this. You have the same equation and they'll say find the value of c if the graph of this parabola does not touch the x-axis. That's another way of crafting the exact same question, that find c if the graph of, well, they'll give you the equation in a function form. F of x is equal to x square minus 5x plus c. Find c if the graph of f of x does not touch the x-axis at all. Or they can say that find the value of c if there are 0 points of intersection between the graph of the function and the x-axis. Okay, so this is just another way of creating a question. But you have to do the same thing. You will have to find the discriminant, put it less than equal to 0. Okay, so that's the geometric interpretation of nature of roots. Okay, so nature of roots, the meaning of nature of roots is that when you have two real and distinct roots, then the graph will intersect the x-axis at 2 points. When there will be one real root, or we say two repeated roots, then the graph will touch the x-axis at 1 point. And when you have 0 real roots, then the graph will not touch the x-axis at any point. Okay?
Okay.
Okay, now we will extend this topic to, we'll extend this concept to the next concept, which is system of linear and quadratic equations. Now in this one, instead of x-axis, we will take any random line. Okay, so I'll again draw 3 cases. There is a parabola, and let's copy. This is not a good parabola. Okay, better than before. Okay, so I'm gonna copy this. Sorry. We are doing system of linear and quadratic equations. First I'll tell you its meaning on, like I'll tell you its geometric meaning, and then we'll do algebraically. Okay, now you have again 3 cases, and now, so in the first concept we did intersection of parabola with the x-axis. Okay, now in this concept we have to do intersection of parabola with any random line. So you will get any random line, equation of any random line, and you will have to find out whether that random line will intersect the parabola at 2 points, or it will touch the parabola at 1 point, or it will not touch the parabola at any point. So let's assume that we have this kind of line. Okay, so this is the case when the line is intersecting the parabola at 2 points. Then you can have a situation like this. This is the case where a line is touching the parabola at one point, and then you can also have a situation like this, that a line is not touching the parabola at any point. Okay, now how you will get the questions? You will get equation of any random line, for example y is equal to mx plus b, and equation of a parabola, so y is equal to ax square plus bx plus c. This is called the system of linear and quadratic equation. System, because one equation is a linear equation and one equation is a quadratic equation. So system of linear and quadratic equation. Now, how will you determine whether, so if the equations are given, then how would you determine that whether these two equations will have one point of one solution? So we also call that this system of equations has one solution, two solutions, or no solution. Same terminologies. So any idea how would we determine if you don't know the graph and we cannot plot the graph, then algebraically how would we determine?
By by solving.
By solving. Okay, so let's say we have y, let me change the color, y is equal to, let's say, negative 2x plus 11. That's the equation of a line, and we have a parabola. Let's take the previous one, x square minus 5x plus 6. We want to find out whether this line will touch, intersect, or will not touch at all. So you said that by solving. So how would you proceed if you have to solve this system of equations?
I would like set them equal to each other.
Perfect. So we would set them equal to each other. Okay. And then what would you do?
I would move the negative 2x plus 11 to the other side.
Perfect. So now what we will do is we will create a new quadratic equation by bringing everything on one side, right? And now if the question asks just the nature of roots, then we would not need to solve the entire quadratic equation. So first of all, we'll create a new quadratic equation. So we'll get x squared minus 5x plus 2x. I brought negative 2x on the other side, then plus 6 minus 11 is equal to 0. So we get x squared minus 3x and 6 minus 11, so minus 5 is equal to 0. So this is our new quadratic equation. And now if you just have to determine whether this system will have one solution, two solutions, or zero solutions, or like if they will touch, intersect, or do not touch, then all you need to do is just find out the discriminant of this new quadratic equation. Okay, so can you quickly find out the discriminant for this new equation?
Is it 29?
29 is negative 4 times 1 times negative 9 plus, yes, that is going to be 29. Okay, so now we are getting 29, which is the discriminant, and 29 is obviously it's greater than 0. So again we will apply the same logic. If the new discriminant is greater than 0, so this line and the parabola will intersect. Okay, or we will say, so first we can say that the line and the parabola will intersect, and we can also say that it will have two solutions, which will be both will be distinct. We can say that d is greater than 0. So 2 points of intersections. You can say 2 points of intersection. Okay. Now let's see on Desmos. Let's verify this. What did we have? Negative 2x plus 1, y is equal to negative 2x plus 11, and we had y is equal to x square minus 5x plus 6. So both of them are intersecting at these 2 points, first point and the second point, right? So that means our answer is correct. Now if you have to actually find out the solutions, then all you have to do is you can simply solve this new quadratic equation to find out the values of x. Okay. The best way would be that you just plot these two equations on Desmos. You just plot the equation of the line, plot the equation of the graph, and you'll get both the answers. You'll get the points of intersections and also your solutions. So two solutions will be, first one is negative 1.206 and the second solution is 4.21. Okay, are we good?
Mm-hmm.
Okay,
Yeah.
but we will not get, the chances are very less that we would get a straightforward question like this. Again, you would get a question in which some constant would be replaced by a variable. For example, like this 6 would be replaced by a variable c, and they will tell you that this system of linear equations has two solutions, then find out the value of c. Okay, and then if you get a question like this, then you have to do it algebraically, right? If a constant is replaced by a variable, you have to find out the value of that variable, that you have to solve it algebraically. But otherwise, if you just have to solve it, then always go for graphing calculator. Okay,
Okay.
so that was system of linear and quadratic equations. Okay, then the next concept is sum and product of roots. Okay, this is becoming increasingly popular on SAT math, sum and product of roots. Anishka, let's say you have this quadratic equation, x square minus 5x plus 6 is equal to 0, and it's a straightforward question that find out the sum and product of this quadratic equation. Can you tell me what will be the answer, or just tell me how would you do it?
I would like solve them for the roots and then add them or multiply them.
Okay, so can you do it right now?
Yeah. The sum is 5 and the product is 6.
Okay, so this is how normally or traditionally anyone would find out the sum and product of the roots. They would first solve the equation and then they would add the two roots and multiply the two roots. But it it will easily take, I think, 30 to 40 seconds, right? 30 to 40 seconds or 20 to 30 seconds. But there is actually a formula to directly find out the sum and product of the roots in just 3 seconds. Okay, and that formula is this. So if you have a quadratic equation, ax squared plus bx plus c is equal to 0, then the sum of the roots is given by negative b over a. Or you take the coefficient of the x term, multiply that by negative, over coefficient of the x square term. Right? So if you look at this quadratic equation, negative b over a would be negative of negative 5 over a is 1. So that's 5. Right? So that's a shortcut that you can use to find out the sum. And the product is given by c over a. Okay? That is constant term over the coefficient of x square term. That's why you got 6 over 1, which is just 6. Okay? And this is actually becoming very popular, this question. So if you know this, you can just find out the answer in, I think, in less than 3 seconds. So this was one small concept that I wanted to tell you, sum and product. Okay, one more thing is, now if you look at the quadratic equation is nothing but a relationship between the sum and the product of the roots. What I mean by that is that every quadratic equation can be written in this form as well. X square minus s times x plus p is equal to 0, where s is the sum of the roots and p is the product of the roots. Okay, so if you know the sum of the roots and the product of the roots, then you can actually write the quadratic equation. So if somebody tells you that sum of the roots is, let's say, 11 and product of the roots is 9, and if you have to write the quadratic equation, you have to do the opposite. Then your equation will be x square minus 11x plus 9 is equal to 0. Okay? Even this is another way the question can be asked. They'll give you sum and product. Then if you know the sum and product, then you cannot find out the roots. Well, you can find out by using some combinations of numbers, but this is a direct way to write the quadratic equation from the sum and the product. Okay? Are we good? Okay. Now, the next topic was special cases, which is again really important. Special cases. So there are some special quadratic equations which can be solved by using some algebraic identities. There are 3 fundamental algebraic identities. The first one is a square plus 2ab plus b square. I'm writing the opposite. That is equal to a plus b whole square. The second one is when you have a square minus 2ab plus b square is equal to a minus b whole square. And third one, can you tell me what is a square minus b square?
A plus b and then a minus b.
Yes, these are 3 fundamental algebraic identities, and these are used. So if you see on the left hand side, the expressions are actually quadratic expressions. Okay, and if in any quadratic equation you find expressions like these, then you can directly apply these identities to get the right hand side. And once you do that, it will be very easy to get the solutions. So this is On the right hand side we have the factored form, and on the left hand side we have the expanded form. Okay, now let's say we'll do 3 examples for these 3 identities. Okay, first one, x square minus 1/2 of x plus 1 over 16 is equal to 0. Okay, let's assume that you have this quadratic equation and you have to solve it. So first thing that will come to your mind is that you can apply all the methods that we did. You can apply a quadratic formula, you can do factoring, you can even solve it on Desmos. Okay, but this method can be also useful if the question is asked that, you know, find out the factored form of this equation. If you have to find out the factored form, then I don't think it can be done using the method of factoring. It would be really difficult to find out, you know, the two numbers whose product is 1 over 16, and when you add them you get negative 1/2, right? So finding out the factored form by the method of factoring would be difficult. So, and on SAT math you will never get a question in which you have to do some really complex calculations or some complex work. If you find yourself doing some really, you know, nasty calculations, then realize that you're not doing something right. There is always a smarter way of solving every question, every SAT question. Okay, so can you guess which identity will be used to solve this equation, Anishka?
The second.
Yes, the second one, because obviously it's not going to be the third one because it has 3 terms. So it is going to be either the first one or the second one, and if the second term is negative, then we will do the second identity. So once you have identified the identity, then the next step will be you have to find out the values of a and b. So to find out a and b, you will look at the first term and the last term. So can you tell me what is a and what is b?
A is 1 and B is negative 1/2.
Oh no, I'm not asking you to compare it with the standard form of quadratic equation. I'm not asking you to compare with this. I'm asking you to compare it with the left hand side of this identity and then tell me the values of a and b. Compare this expression with this expression. So just look at the first and the last term to get the values of a and b.
Oh, so 1 and 1 over 16?
No. So you have to guess that x square is just a square of what? It's square of x, right? So if you do x square, you would get x square, right? So your a is just x. A is x. And then which term's square would give you 1 over 16? So which number's square would give you 1 over 16?
1 over 4?
1 over 4. So 1 over 4 is your b. Okay, so a is x and b is 1 over 4. Okay, so you can rewrite this equation. You can rewrite this equation as x square, and I'm skipping the second term, and the last term you can write it as 1 over 4 whole square. We can do this, right?
Mm-hmm.
And then before applying this identity, like before writing the right hand side, always check, are you getting the second term as well? So in order to check the second term, just check, if you do minus 2ab, then are you getting negative 1 half x? And actually in this case b is negative 1/4, negative 1/4. Okay, so just check, are you getting this? Negative 2 times a is x, so write x. B is negative 1/4, remove this negative sign. B is negative 1/4, so negative 1/4. So if you simplify this, you will get negative 1 over 2x. So we are getting the second term as well. So this can be written as x square minus 2 times x times negative 1/4. This will be plus. So you don't have to do all this, just check if you're getting the middle term as well. Then you can write this equation as the expression on the right hand side. So this is actually whole square of x minus 1 over 4. Is this clear, Anishka?
Yeah.
Now when you have written this equation in factored form, then what will be the roots?
The roots would be 1/4.
Yes, 1 over 4 and 1 over 4. So it is going to have two repeated roots. Okay, and when you have two repeated roots, then we can also say that this equation will have discriminant will be equal to what?
0.
0. And the graph of this equation will touch the x-axis at just 1 point. Okay, so this was one question. We will do two more. Okay. Second, 4x square plus 12x plus 9 is equal to 0. Okay, we will try to do it using one of the identities. Can you guess which identity will be used? Here are the identities.
The first one?
The first one, because all the terms are positive. Okay, now can you guess the values of a and b? So I'm writing it here, a square plus 2ab plus b square. So you look at the first term and the last term to get the values of a and b.
Um, A is 2x and B is 3.
Perfect. So you have a as 2x, b as 3. Now you could directly write that this would be whole square of 2x plus 3. Okay, but if you do not check the middle term, sometimes this step would be wrong, because this question would be also, if I give you something like this, 4x square plus 13x plus 9 is equal to 0, and you think that I can apply the whole square identity by just looking at the first term and the last term, you think that 4x square is whole square of 2x and 9 is whole square of 3, and you just write this expression as 2x plus 3 whole square, then that would be wrong. Okay, you have to check the middle term as well. So middle term should be written as 2 times ab, 2 times ab. So just check that quickly. So 2 times a is 2x and b is 3, so we are going to get 12x, which is the middle term, right? So if you are getting the middle term as well by doing 2ab, then only you can write this expression as whole square of 2x plus 3. Okay, and now can you tell me the solutions?
It's negative 3 and 2. Like negative 3 over 2.
Negative 3 over 2 and negative 3 over 2. Okay, so again this equation will have discriminant equal to 0, and the graph will touch the x-axis at one point, and that point will be negative 3 halves comma 0. Okay, now let's do the third and the final case. 27x square minus 3 is equal to 0. First, identify which identity will be used.
Um, the second one?
Okay, let's have a look. So we have only two terms this time. First term, second term. So which identity has two terms?
Oh, the third one.
Third one. Third one is a square minus b square. Next step, identify a and b. Can you identify a and b? I'm writing it here. A square minus b square.
Is A 3 and B is negative 1?
A 3 and b negative 1. Wait. A 3 and b negative 1, right?
Yeah.
But then a square minus b square, do you think that it's going to be this expression? If you do a square minus b square, that is 3 square minus negative 1 square, then that gives us 9 plus 1, 10. We want this expression. When we do a square minus b square, we should get this expression. So you need to think a number whose square is giving us 27x square, and b would be that number whose square is giving us 3.
Don't you have to like factor take 3 common?
Yes, exactly. So that will be your first step. Whenever in any quadratic equation, or actually in any expression, always your first step will be that just see if you can factor out something. That will always ease out your calculations. So in this equation we can factor out 3. So we will do that, and then we'll get 9x squared minus 1. And now we will apply the identity for these two terms inside the parentheses. Now you tell a and b by just comparing this expression.
Is A 3x and B negative 1?
No, not negative 1, just 1. Well, your b can be both 1 and negative 1, because 1 square is also 1, negative 1 square is also 1. Okay? Okay. So, and it won't affect your final solution. If you take b as 1 or negative 1, it won't affect your final solution. You can take either 1 or negative 1, because ultimately when you do the factors, then one will be positive, one will be negative, and if you take negative 1, then it will be vice versa, because here you'll get positive something and negative of something. The two solutions will be opposites of each other. Okay, so this is 3x square minus 1 square, and I'll make these as curly brackets. And this was a plus b and a minus b. So what will be the two factors, two linear factors?
It'll be 3x plus 1 and 3x minus 1.
Yes. And what will be the solutions then?
It'll be negative one third and positive one third.
Negative one third and positive one third. These are the two solutions. And this 3 that we have factored out, that is actually irrelevant. This is irrelevant um, in determining the solutions. If you ignore this 3 completely, so does that mean, Anishka, here is a very a deep insight. Does that mean that these two quadratic equations will have the same solutions? 27x square minus 3 is equal to 0 and 9x square minus 1 is equal to 0. We have two quadratic equations. We actually solved this one and we got positive and negative one third. And if you'll solve the second one, again you'll get the two same solutions. So what is the interpretation of 3? Is this 3 completely useless?
No, you just add it to the 9x. I mean, you just like multiply it to the 9x squared minus 1.
Yes, but what change is this 3 doing when the solutions are not changing? Both of these equations are having same solutions. So what is the significance of this 3? Like, what is this 3 doing?
Factoring?
No, this 3 will actually um, so if you plot the graph of this equation 9x square minus 1, and when you multiply this with 3, you multiply the entire equation by 3, then the parabola will either shrink or it will flatten out. So if you have y is equal to 9x square minus 1, so this is the parabola, and if you multiply this with 3, so you get 27x square minus 3. So the parabola has shrunk, the green one. That's what that 3 is doing. But both these parabolas have the same points of intersection with the x-axis, positive one third and negative one third. The solutions are same, but the graph will not be the same, and you can see that the minimum value will be also not same. For the red one, the minimum value is negative 1, and for the green one, the minimum value is negative 3. So that's what that 3 is doing. Okay, every point gets multiplied by 3 basically. Well, not every point. The minimum value is definitely multiplied by 3, but the solution will not change. Okay, anyway, so these were the 3 cases, Anishka. And here, if we talk about the discriminant, what will be the discriminant in this case?
It would be uh,
Will it be equal to 0, greater than 0, or less than 0?
it'll be greater than 0.
Yes, greater than 0, because the two solutions are distinct. And if we even look at the graph is intersecting the x-axis at two distinct points. So that's the case when discriminant is greater than 0. Okay, so good, we were able to complete everything. And I think we have completed quadratics as well. Yes, there are some word problems, the questions in which the word problems are given, and those word problems involve quadratic equations. We'll do that tomorrow. And for now, let's review the assignment. So you did this one, right? The one on theorems.
Yeah.
Okay, so you can tell me your answers one by one. And I don't know if you noticed that the answers were also mentioned at the end.
Yeah, I saw. But like for
Mm-hmm.
some of them, like I got an answer similar to what the
Mm-hmm.
actual answer was, but not exactly the same
So can you tell
for a
me
lot of
which
them.
one did you get wrong? We'll review only the ones that you got wrong.
So I got two right, but I don't understand why it's right. And I
Mm-hmm.
got four, five,
Hmm.
6, 7, and the rest I didn't want to do.
So 4, 5, 6, 7 were wrong?
Yeah, four,
Hmm.
5, 6, 7, and two I got right, but I didn't. I don't know why, or like how it's right.
Number 2.
Yeah,
And number 1?
number one got right. Right. Yeah.
Okay, so
Yeah.
let's do it. Let me go to the top. Okay, so first one says, what is the measure of angle ODC? ODC. So this one. So it is going to be 38. Why would it be 38, Anushka?
Uh, I don't know.
What? You said you got number 1 right. So I'm just asking you the reason behind it. It is going to be 38. So how did you get 38?
I kind of just thought that since ODC. Oh, number one. Oh, number. I thought you're talking about number two. Yeah.
Number 1.
Yeah. I got number one. I got 38 because
Hmm.
BDE and BDP are like
Hmm.
both like right angles. So
Hmm.
I just thought that BDE like that part would be 90,
Yeah.
and 90 minus 50 is 52. So that's
Okay,
38.
and why these are perpendicular? Why this one and this one are perpendicular?
Because it's like directly there's a direct line like that's touching the tangent. So
Yeah.
90
So
each.
this, if you remember, we did a theorem that every tangent is perpendicular to the radius at the point of tangency. Okay. So this is a radius. OD is the radius and this PE is the tangent. So tangent is perpendicular to the radius at the point of tangency. This is the point of tangency. So that's why this angle would be 90. And that's why this one would be 38. Okay. The second one will be also 38. Second one is OCD. Where is OCD? OCD is this. We have to find out OCD. We know that this is 38. What can we do to find out OCD? Think about it. Okay, in questions involving circles, um, most of the times you would use this information that um, two radii are congruent. Any two radii or any three radii of circles are congruent. This information is used a lot in solving questions of circles. Radii of circles are congruent. So if you look at this, you have this as a radius and this as a radius. OD is a radius and OC is a radius, right?
Yeah.
So can you now find out this angle? If you look at this triangle,
It would be 38 because
hmm,
the radii is like congruent.
yes, radii are congruent, and then this becomes an isosceles triangle. You have this OCD, and OC and OD are both radii, so they are congruent. So this triangle becomes an isosceles triangle, right?
Mm-hmm.
And in isosceles triangles, the angles opposite to the congruent sides are also congruent. So this angle would be congruent to this angle. And that's why this is 38, so this will be also 38. Okay?
Hmm.
So here in this question, two concepts were clubbed, concept of circles and concept of triangles. Okay, what about the third one? Third one is angle AOD. Let me erase this. AOD. This
Yeah,
one.
that one I did not do.
Okay, I think that's because there has been a gap of some days, because this is kind of a similar question that we did in the class when we were doing circles theorems. So there was one question in which you had to find out the arc length. If you remember, we did one question in which you had to find out the arc length, and this angle was given, and we had to find out this angle. This was exactly similar question. There were two tangents, and okay, so think about this, Anishka. Are you able to visualize this quadrilateral? This is a quadrilateral. It's a kite. There is a type of quadrilateral called kite, but that's not important. But this is a quadrilateral, and in this quadrilateral we have to find out this angle, and we know this angle. Do you know the sum of all the four angles of a quadrilateral?
Yeah, hold on. It's 720.
No, in quadrilateral. 720 is, I think it's for hexagon or septagon, but for quadrilateral, a figure with four sides, the sum of all the four angles. Okay, we did one formula, and that is very important to find out the sum of angles of any polygon. That is given by n minus 2 times 180 degrees, where n is the number of sides. This one is really important from SAT's point of view. So if you have any polygon and you find out you want to find out the sum of all the angles, then you use this formula. So if you want to find out the sum of all the angles of a quadrilateral, then a quadrilateral has four sides, so n is equal to 4. So you do 4 minus 2 times 180. 4 minus 2 is 2, so 2 times 180. So 2 times 180 is 360. Okay, so sum of all the four angles is going to be 360, and then somehow if you can find out the three angles, then you can find out the fourth one.
Yep.
So can you find out this one and this one? So this,
Wouldn't those be the same? Like this, they'll be equal to each other.
yes, they will be equal to each other, but what exactly will they be? So don't look at this one now. Now look at this figure. You have to determine this angle and this one. And remember that this assignment is based on theorems, circles theorems.
Isn't 90?
Yes, 90. Why 90?
Because the tangent and the line.
Tangent and the radius, they are perpendicular, right? So this was
Yeah.
90, so obviously this one will be also 90, and this one will be also 90. So in this quadrilateral, we have 45, 90, and 90. So you can find out the fourth one by subtracting 45, 90, 90 from 360. Okay, so I'm not gonna solve it. let's move to the number 4. Number 4, length of PD.
Oh, that I got right. That's 9.
That's 9. And what's the reason?
Because the quadrilateral AP and BP should be like the same because
Hmm.
um basically at the quadrilateral this when the sides are like this, they're the same.
Um, they look same, but the logic is that two tangents drawn from the same external point are congruent. This is the second theorem on tangents that we did. I think we did it long back, that's why I think you're not able to recall. But if you see, this is this is an external point, and we have drawn two tangents from this point. This is the first tangent, this is the second tangent. So these two tangents are going to be congruent. So if this is 9, this will be also 9. Okay. Okay,
Yeah.
let's move to number 5.
Number 5, I got 40 pi, but like it's not on the answer choices. So
You got 40 pi?
48 pi.
48 pi. Okay, can you tell me how did you get 48 pi? Wait, let me
So
just
I saw
read the question. It says this is 30, O is the center, length of AC is 4 root 3. Area, we have to find out the area of the circle. Yes.
so I took the triangle and it's a 30, 60, 90 triangle. So I put that like the like A as 30 degrees,
Mm-hmm.
C is 90 degrees, and B is 60 degrees. And then I tried to find like the sides of that triangle.
Mm-hmm.
So did I did 2 times 4 square root of 3 to get the hypotenuse, and I got 8 square root over 3. And I did
No, no, no. This step is not correct. In the step where you did 2 times 4 root 3. In a 30, 60, 90 triangle, the hypotenuse is 2 times the shortest leg. So there are two legs, AC and BC. The shorter one would be BC. So first you need to find out this BC, and then hypotenuse would be 2 times this BC. Hypotenuse is going to be 2 times BC. I think you did 2 times AC.
yeah.
Okay, so remember that in a 30, 60, 90 triangle, so this is 30, if this is 60, then first of all, the leg which is opposite to the smaller angle will be the shorter leg. So 30 is smaller, obviously 30 is smaller than 60. So the leg which is opposite to 30 degree will be the shorter leg, and the leg which is opposite to 60 will be the longer leg, and hypotenuse is obviously the longest side. So the ratio is, if shorter leg is x, then hypotenuse is 2 times x, and the longer leg is root 3 times x. Okay,
Okay.
shorter is x, hypotenuse will be 2 times x, and the longer leg would be 2 root 3 times x. So first you need to find out BC, this one, the shorter leg.
Do you divide 4 root 3 over root 3?
Yes, exactly. So that will be 4, and now hypotenuse will be,
Twice 4, so 8.
yes, so this is 8. Then that's the diameter. So now you
Oh,
know.
so then the radius is 4, and then
Yes.
4 squared is 16, so 16 pi. The answer.
Yes. Okay. And how did you deduce that this triangle will be a 30, 60, 90 triangle?
I saw the 30, and like I thought it was a 30, 60, 90 triangle.
No, but why would it be? Because s- if you don't know the correct logic, then in some questions this will work, and in other questions it might give you a wrong answer. You should know the correct logic behind whatever we are deducing. So why, first of all, we can find out this angle will be 90, because this is again based on a theorem that we did in yesterday's class, that angle in a semicircle is a right angle. Remember that? This is the diameter. So we have two semicircles, and this is really important, this theorem, that angle in a semicircle is a right angle. So this one, this is an angle is in a semicircle, and angle in a semicircle is always a right angle. So that's why this will be 90, and so this one will be 60. Okay.
Okay.
Okay, then number 6.
Number 6, I got 0.76, and
Hmm.
I just rounded it to 1, so I got it right, but
Hmm.
I don't really know how I get 1.
And what is the correct answer for this? Is it 1?
Yeah, I just rounded my answer and I got it
No.
correct, but
No, but
yeah.
0.76 and 1, they are not, we cannot round 0.76 to 1. Let's see. So we have to. So how did you get 0.76, Anishka? Can you tell me the steps? Area of the circle is 9 pi, and PR is. Okay, PR is this, that is root 5. Okay. So can you explain your steps?
So I found the radius, and
Hmm.
that's 3. So Q always 3, and then I saw the triangle, and I thought it was a 45, 45, 90 triangle. So I thought QR was also gonna be root 5, and then I tried to like minus 3 and root 5 to get point 0.76.
Okay. So you did that this triangle OPR as 45, 45, 90 triangle?
Yeah,
No, that is not correct, because okay, but why is it again? Whatever you are deducing, there should be a logic for that. Why do you think that OPR would, if something looks like, it does look like OR and PR are same, but we don't know if there is no logic behind it. So why do you think it's going to be 45, 45, 90 triangle?
because that triangle looks to be an isosceles. I thought the angle of O and P should be the same.
Yes, that's true. It does look like isosceles, because PR and OR, they look like they are congruent. But if we cannot prove, unless it's given in the question, like if they had mentioned it that PR and OR are congruent, or we can prove it mathematically, we will not assume anything in a geometry question just by looking like, just by, if things are looking congruent, we will never assume that things are congruent unless we can prove it or it's mentioned in the question. Okay. And I
Mhm.
don't know, it could be isosceles, but right now we cannot say for sure that it's an isosceles triangle. It could be isosceles. Okay, what else can we do? We have to find out QR, that means this length. And we know that OQ is 3, So if somehow we can find out OR, right? If we can find out OR, and then if we subtract OR from OQ, then we'll get QR, right?
Yeah.
So QR can be found out by taking out OR from OQ. So if you do OQ minus OR, okay, that's one thing. And OQ is 3. We need to find out OR. Okay, what else do we know? Again, use the information that radii are congruent. Radii of any circle are congruent. We know PR is root 5. We have not used this information. And here you see two radii. OP is also a radius. OP is also a radius. Yes.
Yeah.
Yeah. So OP will be also 3. And now, how can you find out OR in this triangle, Anishka? You know this is 3, this is 5. How can you find out the missing leg?
The Pythagorean theorem.
Yeah, can you find out OR? I think it's
Yeah.
9 minus.
It's 2.
Yeah, that is 2. Now see, this is coming out 2, but that means this is not an isosceles triangle, right?
Yeah.
And root 5 is what? 2 point something. It is very close to 2, but is not exactly 2. What is the exact value of root 5? Root 5. Root 5 is 2.2. 2.23. So it's very close to 2. So that's why it looks isosceles, but it's not actually isosceles. Okay, so you have OR as 2. So that's why QR will be 3 minus 2, 1. Okay?
Okay.
Alright, so I'm removing everything. Number 7.
7. I didn't know how to do.
Okay, so we can do it right now.
Well, I got actually no. I got 63. I think something like that.
63.
Yeah.
Okay,
Yeah.
so we have to find out the perimeter of triangle PQR. Okay, can you tell me how did you get 63?
So I okay. So I thought that PB was also gonna be 9.5,
No,
and then
no,
yeah.
this step is not correct. PB won't be 9.5 because again it looks like RB and BP, they look like they are congruent, but if you apply this logic, then this and this should be also same, right? Like if this and this are congruent, then this and this should be also congruent, and this and this should be also congruent, right? Isn't it? Okay,
Yeah.
why do you think that this will be also 9.5?
Because I thought that since it was a tangent, it should be the same.
No. So from that logic, this should be also equal to this. Okay, but you can have a tangent in one direction like this and in other direction just this much. So the theorem is, now if you remember the second theorem, that tangent drawn through same external point are congruent. So this one, PA and PB will be congruent, and QC and QA will be congruent, and RC and RB will be congruent. because the tangents drawn through same external point are congruent. So here the external point is P, here external point is Q, and here it's R. Okay,
Yeah.
so that means this will be 12, this will be 9.5, this will be 6. Now can you, I think now you can find out the perimeter, right? You have to just add all these numbers.
Yeah.
Okay, let's move to number 8. Number 8. What is the length of PQ?
Oh wait, would QR also be 10?
QR is 16.
Oh,
Did you mean OR?
yeah.
Yes, OR will be also 10 because OR is a radius and OP is a radius. So I
So
think
uh,
now it's easy.
is that D?
I don't know the answer. I have to check number 8. 8, number 8 is C. You got D?
Yeah, because like
You applied Pythagorean theorem?
yeah, I did 26 squared plus. Oh, that's a hypotenuse. Never mind.
Yeah, you do minus 10 square.
Oh yeah, see.
Okay, this you really cannot afford to make these mistakes, Anishka. Um, because if you know the concept and then we are making some minor calculation mistake or some concept mistake, then you would lose points for nothing.